What's up, guys? My name is Connor. Today we're back with more Brickadia, and in this episode we're going to look at how I built this elevator. It's a 5-floor elevator. It can be infinitely expanded as far as we want it to go, as long as actually the slider block lets us scale that far. And it's a simple elevator system that lets us press any button to call the elevator to a specific floor, and then of course we can go into the elevator and we can press any button and it will take us to that specific floor. We can, of course, take the stairs if we really want to walk all the way down. I actually decided to do this build because Dapper was telling me how I should build some logic stuff and kind of show people how some of the logic in Brickadia works. And I was like, all right, cool. So this is the elevator circuit. It's actually really, really simple. We'll go through how to set it all up and we'll build a little sample elevator ourselves. The entire thing is using that magical blend block in the logic. So we're storing the entire elevator value in the blend block. And of course, we can expand this out. This is literally just a simple circuit to have an elevator move up and down between floors. It doesn't do any of the fancy stuff like opening the doors and that sort of thing. We can talk about doing that in another episode, but yeah, for now, this is how you set up a basic elevator. So let's get to it. The first thing I did is I built this prefab, and it's pretty much just a simple single floor prefab. You'll notice there's a cross brace in the middle, and that's just because when you line up prefabs, you have to sort of place them. So if I go to the prefab menu, I can load my prefab here, and we'll just paste it. And then you can see it gives us one elevator. I'm just going to paste it a little bit off the ground. And then, of course, we just line up the next floor. And we can line up the next floor, right? And so there's 3 floors, right? I don't want to go too advanced. We could do 4. You know what? For this one, we'll just do a simple 4 floor. That one's 5. This one's 4. It doesn't really matter. And then we got to basically add a slider in to run our elevator. So I'm going to put a little extension block here in the middle. Don't really need it to be that big, but we'll do that. And then we're gonna take our slider, of course, and we wanna use the servo slider, because the servo slider, we're basically gonna give it a specific position we want it to be in. And we're just gonna drag that up the whole height of our elevator. Again, we can go up. So how can I go with this? Is there a limit? 100. Okay, so I guess we can make an elevator that's a total of 100 blocks high. The one over there is about 50. So we could do a 10-floor elevator, and then we'd have to switch to some other system or to a different elevator or something. I'd have to think about that. We'd have to extend the slider out to another slider. But anyway, we can do a 10-floor elevator, so that's not bad. So let's just drag this up. Again, we'll grab that slider, drag that up. Whoops. And we'll just drag it up like this. And then we'll drag a block out here, like so. And then we'll put another block on top of this. And we'll just make this into our floor. Whoops. Sort of got to make sure. It's kind of weird. You got to kind of offset it into the slider a little bit. There we go. And it'll work just fine. It won't clip into it or anything. And then that way we can make our entire floor. And then we'll just grab our resizer and drag it out that way. So there we go. So that's our elevator floor. We'll paint that a different color. Just, you know, there we go. It's a gray. Perfect. So that's essentially the whole mechanism. We'll put a little bit of a space here at the back for our logic, just to, you know, have some extra workspace. Of course, you could hide all this logic later. The thing, too, is you can make logic invisible. So you'll notice that these wires sort of come out of nowhere. There is a series of invisible blocks there, and that's just to hide all these wires. We could also do all this with nodes and make it all look pretty, but these are all the wires that go to all the different buttons, and I just to hide them, we make the OR gates that they feed into invisible, and then all of a sudden the whole system, you know, disappears, right? So that's that, and then we basically need, the last thing we need in terms of physical setup is we just need to put our buttons on. So we're just going to use the square buttons again, and not a big deal. I need to make a pillar inside of here. For the buttons inside the elevator. We have 4 floors, so we're just going to rotate this out and just go 1, 2, and 4. Good enough. Perfect. Like that. And then on each other floor, we'll just put a random button. On mine, I was really careful to make sure the spacing was all right. Here, who cares? It's close enough. Something like that. So that's it, and that's all our buttons. Now, the logic itself is actually relatively simple. Again, we're not doing any of the crazy stuff, so I will show at some point in time I'll build an elevator that actually does like what proper elevators do. So the next thing we'll do is we'll work on how to get the doors to automatically sync up. You can use the @target system from the slider. It's really, really cool because you can actually like figure out where the slider is at any point in time. This game is awesome. You can do such crazy stuff with the logic. So we can take the slider position, we can measure that, and then we can actually use that to open the doors only when the elevator gets to each specific floor, and you know, it's actually really, really cool stuff. So we can do that, and then the other thing we need to do as well, which this elevator won't do, but we'll do eventually, is we need to make an elevator where the entire system is like a real elevator, so if you press 10 buttons, it'll remember all 10 buttons, and it'll stop at each one of the floors as it passes them, clearing each of the buttons. We can totally do that with some memory. It's going to be sweet. That'll be a little bit more complicated of a circuit. We'll do that at a different time. Anyway, what we're going to need for logic is pretty simple. I'm going to grab a rerouter just to move stuff around. I'm going to grab an OR gate. Also, I love the fact that when you click on a thing, it adds it to the furthest slot of your inventory and just shunts the rest of your inventory away. It's so magical. I can't even describe that. It's actually like the coolest thing ever. Anyway, we need an OR gate. We need a blend gate, of course. We need multiplying. We need add. And we need a buffer with ticks. And I think that is all we... Oh, and we need a single edge detector. So the first thing we're going to do is basically we're going to put down our multiplication gates and our OR gates to match the number of floors we have. So we need... I guess we can start with the OR gates. So the first thing we need is we need an OR gate for each of the buttons. So we have 4 buttons. So that's 4 OR gates. We'll just space these out a little bit. 1, 2, 3, and 4. Right, and basically the reason it's an OR gate is because you have 2 buttons. You have the call button on the one side, and then you have the button inside the elevator. So if we were to hook all these up, which we can just do right now, really, you have this button, which is the button on the inside of the elevator. So that's floor 1, and of course the call button for floor 1 is going to be this very bottom one. And again, we can hide, if we make those OR gates invisible, these wires will go invisible, right? So if we take this OR gate and we just turn it with the applicator and make it invisible, then the wires disappear, right? But we're leaving visible for now. It doesn't really matter. But we could also, you know, do nodes. You can make it look pretty. There's a million ways to do really cool stuff in this game, and it's kind of insane. Anyway, so gate number 2. This is going to be the second floor stuff. Again, the position of the button doesn't really, like, which side of the OR gate it goes to on this doesn't matter, as long as you're feeding them to the inputs. And then number 3, we'll do that. And 4, of course. All right. And perfect. So there we go. So those are all hooked up. Now, on each one of these, I'm going to put a node, because I need to use this for something else. So we'll put a node, like, kind of just next to it, because these signals need to do 2 things. So the one thing they're going to do is they're going to give us the number of the floor, like the distance up the slider that the floor is. And we're going to do that with a multiplication block, right? So we can actually do something really cool with multiplication block. So if we take a multiplication block and we put a connector and we connect it into the one side of the multiplication block, now this is basically converting our binary signal into a number. And then we're going to take the other side of our OR gate and we're going to feed it to these connectors for now. And this is just an organization thing just to get them out of the way. Again, you could make all this super compact. You could do whatever you want with it. I'm just trying to lay out the circuit nice and large. Now, with our multiplication block, we're going to take our applicator and we're going to use this to set like the constant of which value our floor is. So the first one's going to be 0, right? Because it's at the 0th level. It's at the very bottom. The second one, if I remember, well, you know, I could check these ones actually, because these will be presumably the exact same measurement. So the second one should be 12. The third one should be 23.25. Don't ask. I don't know why it's that, but it is. And then the next one's 34.5. So 12, 23.25, and 34.5. So we can just go like this. Boom. Done. And then basically, I think the problem is I made the floor out of like a really thin plate here. And I think that's where the 0.25 comes in. But I don't understand why the first one doesn't have a 0.25, why it's just like an even 12, and every floor after that has a 0.25. It was 35.5, right? I think. Doesn't matter. We'll find out if it's wrong. All right, so that's that. So now we have numbers coming out of them. So now what we have to do is essentially add the numbers together. And this is just to get them all into the blend block. So right now I have 4. If I had more, I would have to extend this out just like further. I just make a web, right, of adders. So essentially, like, what we're trying to do, and we can do this as many times as we want, but like this one can go into here, for example. It doesn't really matter, right? And they're just gonna, and then we just add them all through like a big web. And the reason why is because I can't hook, or at least I don't know of a way to do it. I don't know of a way to hook multiple inputs into like a single, like this is 2 inputs. I can't hook, if I try and hook a third in here, for example, see it overwrites the other one, right? So I don't think there's a way to do it other than just make a big web of addition blocks until you get down to this. Now, obviously this is super inefficient. We don't need to use this. This is just, you know, proving the point. We only need 2 because we only have 4 floors, right? So we can just go like that instead, but same idea. And then on the other side, we have to do the exact same setup, but with OR gates. And this is for the binary input of the signal. So again, this is where we're splitting the signal. This is like the signal to recognize that you've pressed some button, basically. Because we're doing two things now. We're gonna have a blend block, and on one side of the blend block, we need to feed it the number of the floor that we want to store. And on the second side of the blend block, we need to feed it a signal to say, hey, write this to the blend block. So when you press the button, you're gonna write the number that you're trying to go to, and you're gonna write to that blend block, right? So on this side here, what we do is we take this and we give it a tick edge detector, basically, because we don't want it to hold multiple times, because it will keep adding to that blend block as we're holding the input. Sometimes don't ask, trust me, I went through it on the other one. I had added it after the fact. And then we make our blend block loop, and this is essentially our elevator memory. And I guess we can put this more up in the middle, but this is our elevator memory. So blend, and then we have a little tick delay. And the blend block, if you guys remember, uses a formula of A, B, and then your blend value. And the formula essentially is that your output is equal to A or B if the blend is greater than 0 or less than 0 or greater than 1. But if it's between 0 and 1, then it applies a formula of like A times 1 minus, whatever. It doesn't matter. We're not using it for the formula. We're going to take the rising edge, and we're going to feed the rising edge into our blend. So essentially what's going to happen is the rising edge is either going to be a 0 or a 1. So it's either going to output the value of A or the value of B. When it's not outputting anything, it's going to be the value of A, which is this. So we have this set up as a loop. And essentially what happens is it's going to feed A back into itself. So as it doesn't output anything, it will always feed back its original number, which means it's going to store whatever number that is in memory. And then we're using B here as our input from the floor. So when we press this button, what's going to happen is it's going to switch this to a value of 1 for a very, very short time. While it flips this to a value of 1 for a short time, this path is lit up with the number based on which one of these is lit up. The only one of these that is lit up is the button of the floor you're pressing, because this becomes a 1. These are all 0 times something, right? And so they end up being nothing, because 0 times something is 0. But as soon as you hit that button, it sends a blip to this, and all of a sudden it becomes a 1, so it's 1 times whatever your number is. That goes to the addition. All the rest of the additions are 0, except for yours, so it's the only number that comes through, gets fed into the blend block, and then as a result of that, it gets stored in that B value of the blend block for that split second while this is a 1. As soon as this flips back to a 0, that B value is still being output, which then gets written into the A value, and thus it stores it in memory. Really, really cool system. It's fantastic how this works. And then, of course, we just take that, we put a node here just for fun, just so that it keeps our wire organized. We take this node, we feed it back into that, and then we take that node and we go to our slider, and we grab our slider and we feed it to the target position. Now, with this setup, if we want to change our elevator speed, stuff like that, we just come in here with the applicator and we can do that. Obviously, we can put wires into all those parameters as well and do it that way. But essentially, that's it. Like, that should be a working elevator setup. So now if I just get out here, and we go there, that's the first floor. This is a nice little wiring setup. Oh yeah, see if I press 3, are we on the 3rd floor? I think we're on the 3rd floor. It's very quick. Yeah, no, already on the 3rd floor. It's very fast. And then 4th floor. Oh, see, I got that number wrong. Bet you it was 34. So, no problem. Again, when I was setting this up, I just sort of guessed until I got them right. So I think it was 34.5, right? There we go. Now, the elevator isn't going to move to the new floor or anything, even though I just changed it, because technically speaking, it's already done its movement. It has the value that I gave it to the blend, but now if I press this, it should set it to 34.5. And there you go. That's pretty close. But yeah, pretty simple setup. We could go, up to 10 high, and then, of course, if we want to get rid of all those wires, which we're going to do right now, we just come over here with our applicator. We go like this. We edit our... Whoops. We go to our logical OR, and we just turn it off. There we go. And we go to a logical OR, and visibility off. And basically, it'll still show the wires right now, and then as soon as I put a tool away, all the wires disappear. And look at that. Beautiful elevator. Really simple system. We can call buttons to floors, and we can go to other floors. And obviously, like I said, we still have to, it auto does the damping, by the way. That's just a setting inside the slider that you can play with. Like, whoops. There's a setting in the slider that you can play with for that. Like acceleration, I think is what it is, and damping. Like, so it's really, really cool. But there you have it. It's a really simple system, easy enough to set up. Like I said, it's sort of just a auto call elevator, let's call it that. If I press any button while it's mid-travel, it's going to just automatically go to whatever button I pressed, and it's going to just immediately respond to that, right? So it doesn't It doesn't really work the way a normal elevator would. You can't mash all the buttons. And as we could do this with micro buttons like Dapper was pointing out to me, and then have a panel of, you know, a ton. So let me know what you guys think in the comments down below. Make sure you hit that like button, hit the subscribe button. We are limited, of course, by the height of this this slider panel. So I think we could only make, with this floor height, 10 high elevators, which I thought this floor was, I guess it's like twice the height of a dude, but I like it because it's kind of like a nice jump height. Could be a little shorter. But yeah, if you guys have your own ideas for things you wanted me to try and build, let me know. There's some cool tutorials in this game, and I enjoy the tutorial worlds as well, but I also enjoy figuring out some of the logic for myself. And, you know, there's a million ways to do this. This is probably not the best way and the most efficient way to do it. This is just the way that I like to do it, and of course, it's kind of easy to infinitely expand this. It just takes up a little bit of space with this input stuff, but this is the whole, you know, guts of the circuit, and it's kind of really simple. And then we'll do some target position stuff to actually get it to activate doors and have the doors on sliders, and we'll figure that out. And then we'll have to do a whole memory system, which will be a whole other ball game. But yeah, let me know what you guys think. Like, subscribe, and as always, I hope you guys enjoyed this video, and we'll see y'all next time.